So let me say, guys, this practice final is almost identical to the actual final. All right, almost identical. The only difference is right here, it's open response. The actual final is multiple choice. So technically the final itself should be way easier than this, right? Because you're going to have 4 possible answers visible to you. But let's go through each one of these open response questions and let's explain every single one of them. So on number 1, it says solve this quadratic trinomial equation. We can either use we could use a quadratic formula, right? The quadratic formula always works on any quadratic equation. But if your a value is 1 and you have a x squared or a b squared or h squared, why not try to factor, split, and solve, right? If it's factorable, you might as well factor it, all right? So you could use a quadratic formula, but this is way easier, way faster. All you have to do is think what times what is the c value that if you combine together is the b value. Now you might need to make a list, right? And of course you could use a calculator. How could you get negative 18? Negative 1 times 18, negative 2 times 9, negative 3 times 6. That's all the possible ways of getting negative 18. And which pair of numbers combines together to give you a positive 7?
The negative 2 and 9.
The negative 2 and the 9. So all you're doing is plugging in the negative 2 right there. Or you can put it on the other side, but as long as one's a positive 9 and one's a negative 2, you are good. Now that's factoring. We factored it. Yes. Now let's split it using zero product property and then solve it. So if you have something times something and it equals 0, the first something could be 0, the h minus 2 could be 0, and also the h plus 9 could be 0. Okay, and solve both of those simple equations, you're going to end up with h equals 2, that's one answer, and the other answer is going to be h equals negative 9, because you subtract 9, h equals negative 9. And those are your 2 answers to number 1. So far, we should all have an A+ on the final exam, huh?
No.
Number 2, let's graph the function, a quadratic equation. Now, there's many ways of looking at this. You could look at this as ax squared. There is no bx, so b would be 0, and the c value is the number all by itself. So you could look at it as a standard form quadratic trinomial equation. That way you could find the vertex using the vertex formula, x equals negative b over 2a. Or the better way of looking at this problem is as if it were in vertex form. You guys remember vertex form? It's y equals a parenthesis x minus h close parenthesis squared plus k. If I could make it look like that, then it's really easy to find the vertex. It's simply h and k. You think opposite on h. So let's pretend that there's some parentheses around that x. In other words, let me rewrite it as y equals negative 2, open parenthesis, x minus, there is no addition or subtraction in the blue parenthesis right there, squared plus 3. So in reality, the h value is 0 and the k value is 3. So now we know our vertex, which is the most important point on graphing a parabola. That vertex is the opposite of negative 0, which is positive 0, which is still 0. And the k value is 3. You take that for what it is, all right? If it's a plus 3, your k value is going to be 3. If it's a minus 3, your k value is going to be negative 3. Right here you think opposite. Right here you take it for what it is. Everybody cool? All right. Let's move on. So we have the coordinate 0, 3. That's our vertex. 0 on the x, 3 on the y. Everybody should put that point right there. Step 2 on graphing any parabola is to draw your axis of symmetry. In this case, it's not even necessary because it's right through the y-axis. It is the y-axis. And now we need more points. So you could go to an input-output table, or you could use the pattern is 1, 1, 2, 4, 3, 9. Why could I use the pattern 1, 1, 2, 4, 3, 9? Because, oh no, wait, I can't use that pattern 1, 1, 2, 4, 3, 9. I have to modify it because the a value is negative 2. Actually, that's great. Look, the a value is negative 2, right? A value is negative 2. Which means I have to modify these outputs from the pattern that I have memorized. I need to modify the 1, the 4, and the 9 according to that new value of 2. So I need to actually go through and put times 2 times 2 times 2. Now I know some of us are thinking, oh, but it's a negative 2. Shouldn't I be multiplying by negative 2? It doesn't matter as long as you remember that your negative means that it's going to be opening down. Okay? So we just multiply these second numbers by 2. And we're going to end up with 2, 8, and 18. So what's your actual pattern? It's not 1, 1. It's 1, 2. What's your actual pattern? It's not 2, 4. It's 2, 8. And then 3, not 3, 9, but 3, 18. Okay? This was the modification. If you don't know how to do that, you need to learn. Because if the A value is anything other than 1, you're going to have to modify the pattern, the second numbers on your pattern, according to your A value. So our pattern is 1 over and 2 down. Why down? Because the A value is negative. So 1 over, 2 down. Let's put a dot right there. Let's go back to the vertex and let's go 2 over, 8 down. 2 over, 1, 2, 3, all the way down here, 8 down. It'd be right here. And of course, 3 over 18 down is going to be off the graph. 3 over 18 down is going to be off the graph. I don't have to do it. Let's map over those blue points across the reflection line called the axis of symmetry, and you will end up right there and down here. And then all you have to do is connect those dots, and you have that perfect kind of narrow parabola opening down. And that's it. Now, you didn't have to use the pattern. You could have plugged in numbers. Like if you wanted to, you could use the XY table and plug in the number 1 and actually do some math. Think about it. Plug in a 1 right here where the X is at. 1 squared is 1. 1 times negative 2 is negative 2. And negative 2 plus 3 is 1. And of course, the calculator does that for you. So if you input a 1, you get an output of 1. And that is a coordinate 1, 1. Where's the location 1, 1 at? It's right here. 1 on the X, 1 on the Y. You'd get that blue dot anyway. So if you prefer using an input-output table, go for it. Look, I could plug in the number 2. What's going to happen if I plug in the number 2 right in here? Well, 2 squared is 4, and 4 times negative 2 is negative 8, and negative 8 plus 3 is negative 5. So I guess one thing to remember, if you're using the input-output table, the XY table, this is not a pattern anymore. These are actual coordinates on the XY plane. So for example, 2, negative 5, it's not from the vertex, it's on the actual plane. So if you're at 0, 0, 2, negative 5, it'll get you to that blue dot. So it's totally up to you if you prefer input-output table or if you prefer modifying your 1, 1, 2, 4, 3, 9 pattern. It's totally up to you. A couple other things that you could state that they might ask on the final exam is, what's your domain of this thing? X equals all real numbers. How about the range? What's the range of this thing? Y is less than or equal to the Y value of your vertex, which is 3. How about the axis of symmetry equation? X equals the X value of your vertex, which is 0. Right? How about your Y-intercept value? 3 in this case. Yeah, it crosses the Y-axis right here at 3. So that's all you could possibly state. I mean, you guys are way ahead of the game when it comes to parabolas, I think. I don't think they're going to ask all that on the final, but it's good to know they might. All right. Now, number 3, we got to go way back in time and review geometric sequences. All right. Now, there's a couple things about sequences that we've learned in the past. There were arithmetic sequences and geometric sequences. You guys remember that? Vaguely. The arithmetic sequence had a common difference between each of the terms, a common difference. A geometric sequence has a common ratio in each of the terms, all right? So they tell us here to write an equation for the nth term of a geometric sequence. So they're telling you that there is a common ratio. Now, how do you find the common ratio? You take a number and you divide it by the previous number. Okay, so let's write down a little r right here, and let's write down that common ratio. You're going to write 162 over negative 486. Could somebody do me a favor and grab a Casio calculator and just type in that fraction, 162 over negative 486. And the Casio calculator will reduce it for you, and it'll be a negative 1/3. So ladies and gentlemen, our common ratio is negative 1/3. Okay? That's our common ratio. Now we're not done yet because they didn't ask for the common ratio. They asked for an equation of the nth term of this geometric sequence. So here's another thing that we need to memorize. Actually, I think I might provide this to you on the test, but here's the geometric sequence form or formula that you need to memorize. It is a sub n equals a sub 1. A sub 1 is the first term on your list, and that makes sense that you start with the first term on your list, times the common ratio in the parentheses to the power of n minus 1. To the power of n minus 1. So we now know this common ratio because we took any number and divided it by the previous. You could have done the same here, divide this one by this one, it would still give you negative 1/3 on the calculator. Anyway, we still need this a sub 1. What is a sub 1? A sub 1 is what? It's the first number on your list. What's the first number on our list? 1,458. Okay, so now that we know our a sub 1 and our r, we could plug in the a sub 1 and the r right here and right there, and we should have our equation. So let's write it out. A sub n equals 1,458 times r, which is negative 1/3, to the power of n minus 1. Now that's the equation, and they wanted an equation. So here's our equation. This is part of our answer. On your final exam, you're going to have to identify that correct equation on the multiple choice, but there's still more. This is the machine that produces the list. All right, this is the machine that produces the list. Ladies and gentlemen, if I plug in a 1 right here, check this out. Plug in a 1. What's 1 take away 1? 0. What's anything to the 0 power? It's 1. And what's 1 times 1,458? It's 1,458. And that's the first term on your list. So this is the machine that produces the list, right? If you plug in the number 2, it'll actually give you this next number. If you plug in the number 3, it'll give you the third number, right? So this is the machine that produces the list. And the second part of this question says, that's why I said there's more to it. The second part says, find the 7th term. So what are you going to be plugging in right here into the end? A 7, right? So we're going to plug in the 7 right in there. We're going to have a sub n equals 1,458, parenthesis, negative 1/3, close parenthesis, power of 7 minus 1. But you could just do that in your head and put a 6 right there. So let's all do this with the calculator. And all right, if you type that in correctly, as it is, into the Casio, it will give you the answer 2.
So is this your answer?
Yeah, so on the multiple choice part of the final, it'll say write the rule. So this will be on there. And also the 7th term. The 7th term on this list is the number 2. Now you're probably thinking, how the heck is it the number 2? Well, think about it. This is going smaller and smaller and smaller, and it's jumping from positive to negative to positive to negative. The 7th number on this list will be a small number, which will be 2, and it will be positive. Moving on to number 4. Okay, number 4, it says solve. And if you have a quadratic equation, of course you want to set it equal to 0. So let's subtract 6x. Subtract 6x, which you can't really do, so you're just going to rewrite the whole thing. 3x squared minus 6x minus 4 equals 0. And now that I have it equal to 0, now I could identify the a value, the b value, and the c value of this standard form quadratic trinomial equation. Now, you can, if you want to, use the quadratic formula, or you also could attempt to factor, split, and solve. But factoring, since your a value is not 1, it's not that easy, right? You'd have to go through that long process, a times c, and then you make a list of the multiples of that number, and so on and so on. So what do you guys want to try? You want to try factoring, or do you want to go straight to the quadratic formula? Sometimes factoring doesn't work, and the quadratic formula always works. Now, check this out. Here's my advice to you. On the test, on the multiple choice, if you see that your answers are kind of like 3 plus or minus square root of something divided by something, that should give you like a hint, oh, I need to use a quadratic formula because my answer is going to end up like that, right? But if you don't see answers like that, if you see nice answers like 2 and 4, 1/2 and 6 or something like that, if they're nice answers, then you know it is factorable, okay? So it's totally up to you guys. You guys want to try to factor, or you guys want to use a quadratic formula? Quadratic formula? All right, so the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac divided by 2a. That's right. And we're going to rewrite that formula, but with parentheses instead of the letters. So I have negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So we know that our b value is negative 6. Put the negative 6 where the b's belong. Put the a value of 3 right here and down here where the a's belong, and the c value of negative 4 over here. So once you have the quadratic formula, the minus minus changes to plus plus. That's easy. Let's do the discriminant either with the calculator or together right now in our head so we don't make mistakes. What is negative 6 times negative 6? 36. So I'm just going to write down a 36 since I'm not using a calculator. And then I want to call this a negative 4. What's negative 4 times 3? Negative 12. And what's negative 12 times negative 4? Positive 48. Now, if you guys get confused with this math, with PEMDAS, type it all into the Casio, hit equal, and it'll give you your final answer, because this is not even the final answer yet. What is 36 plus 48? That's 70, that's 80, 84. Okay, so my new quadratic expression here, or quadratic formula simplification step is 6 plus or minus the square root of 84 divided by 6. Now, 84 is not a perfect square number. We need to either rewrite it with multiplication to get a perfect square number, or again, you could simply type in the square root of 84 with the Casio, hit equal, and it'll simplify it for you. I just did it on the calculator. I typed in square root of 84, and it gave me the square root of 84 on the calculator. It gave me 2 square root of 21. Okay? 2 square root of 21. So let me rewrite it. It's going to be 6 plus or minus, but instead of square root of 84, I want to put 2 square root of 21, because the calculator gave me that, still all divided by 6.
You could do the simplifying.
Exactly. Now, on the multiple choice answers, there's going to be one answer where they cancel the 6's, and that's incorrect. You cannot cancel 6's if you're adding or subtracting. If you're ever adding or subtracting, you got to look at all 3 terms and see what you could divide all 3 terms by. So I could divide all 3 terms by what? By 2. So if I divide 6 divided by 2, that'll give me a 3. 2 divided by 2, that'll give me a 1. 6 divided by 2, that'll give me a 3. So what do I have left? I have the 3 plus or minus 1 square root of 21. Now that 1 in front of the square root of 21 is totally unnecessary, and they're not even going to write it on the multiple choice. They're just going to leave it square root of 21, and it's still all divided by 3. And that right there, ladies and gentlemen, is your final answer. So that's good that we did not try to factor, because this one's not factorable. So quadratic formula always works. Yes, but on this one you would not be able to factor it. Like you would go, a times c, 3 times negative 4, you get negative 12. When you start thinking of the multiples of negative 12 that combine together to give you the b value, you're not going to be able to find it because it's not factorable. All right. So if it's factorable, heck yeah, it's way easier to factor, split, and solve. But if it's not factorable, then you're going to have to use a quadratic formula anyway. Number 5. Right here it says completely factor. I mean, this is like a free point, right? Why? Because it's a quadratic trinomial expression. The a value is 1, which means this. Parenthesis, 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 g right there, and simply think, what times what is 28? That if you add together is 11. You might need to make a list. 1 times 28, 2 times 24. No, 2 times 14. Sorry. 3 times, no, it doesn't work. 4 times 7. 5 doesn't work. 6 doesn't work. Okay, so that's it. There's just 3 possibilities. And yes, 4 and 7 combines together to give you 11, but you want the b value of negative 11, not positive 11. So it means you have the right numbers, you just have the wrong signs. So you change the sign and you change the sign. So it's going to be g minus 4 times g minus 7, and that's it. You're done. It's like a free point on the test. Number 6. Man, we're jumping. There's all kinds of stuff on this final. It's everything we've ever learned, right? So we're jumping from factoring to quadratic formula to solving systems of equations. And this system right here is actually very easy to do. It's another easy point, but if you've never, or if you haven't practiced it in a long time, you're going to get confused. When you have a system like this, 2 equations, they want you to solve for the value of x and y. The easiest thing to do if it's already lined up is to use linear combinations, right? The elimination method. So if you combine the lines, it's ready to rock because the positive 3y up here and the negative 3y down there will cancel out. So you might as well just combine them. Combine them, these guys disappear. You end up with a negative 24 with an x. The equal sign comes down, and negative 107 minus 85 is negative 192. So for my final step here on this simple one-step equation is to divide by negative 24. Divide by negative 24. I don't know what that is. I want to do that on a calculator. 192 divided by 24. Negative divided by negative is positive. The final answer is 8. So x equals 8. So you have one answer. You need the other answer. What do you do to find the other answer? Plug it in. Which one do you want to plug it into? The top one or the bottom one? Top one says negative 10x, but I want to leave it a parenthesis, plus 3y equals negative 107. So why did I leave a parenthesis in place of x? Because I already know that x equals 8. I'm going to put that 8 right in there. So the 8 goes right in there, and I do the math. I end up with a negative 80, because negative 10 times 8 is negative 80, plus 3y equals negative 107. So I have a 2-step equation here in red. I need to add 80 to both sides, which ends up being negative 27. That's right. So we end up with 3y equaling negative 27. Final step is to divide by 3. Divide by 3. So y will equal negative 9. So ladies and gentlemen, we have our x value up here. We have our y value down there. And I'm not sure, I don't remember how exactly they give you the multiple choice answer. They might give it to you as a coordinate, which would be 8 comma negative 9. Or they might tell you x equals 8 comma y equals negative 9. Either way, you need to know how to identify those answers. Number 7, it also says solve the system. But right here, as you can see, they're not lined up. X is not on top of x's, equals not on top of equals. So you could either line them up by modifying this top equation, or you could substitute. Since y is by itself on the top one, I am going to substitute this y value into the equation that's on the bottom where the y is at. So this is called substitution. So what do I get? I'm going to have 3x minus 2, but instead of y, I'm going to put the parentheses equals 52. Now, why am I putting the parentheses instead of y? Because y is 4x plus 14, and that's what I'm going to plug in, 4x plus 14 instead of y. So we now have a multi-step equation that we need to simplify first and then solve, and we'll have the answer for x. So let's start simplifying. This negative 2 times 4x, that's negative 8x. Negative 2 times positive 14 is negative 28. Bring down the equal sign, the 52. Bring down this 3x out in the front. After distributing, you're supposed to try and combine like terms. You have the 3x minus 8x. That is a minus 5x. Bring down the minus 28, the equal sign, the 52. You now have a 2-step equation. Let's get rid of the minus 28 by adding 28. What you do to one side, you do to the other side. You're going to end up with negative 5x equaling 80. Then we divide by negative 5, divide by negative 5, and we will get negative 16. So x equals negative 16. Of course, use a calculator if you're confused. So once you have one answer, you plug it back into any equation you want to find the other. I want to plug it into the top equation. It looks easy. Y equals 4x plus 14. And of course, x is negative 16, so let me plug that in right in here. So that's a negative 16. And with the calculator, you could do 4 times negative 16. That's negative 64, right? And then plus 14, that's right here. You end up with negative 50 as your y value, right? Y equals negative 50. So your answer to number 7 is negative 16, comma, negative 50. Or they could write it out as x equals negative 16, y equals negative 50. This video is already way too long, so we're going to pause it right here and pick it up on the next video.